Very good morning to everyone. So I'm Anup. So I'm taking care of simulation technical activities in Beacon, Bangalore. So today I'm going to showcase you new features in SolidWorks Simulation 2020. Let us start with the SolidWorks Simulation user interface. We have enhancements in this. The one of the user interface enhancement, that is using the Shift C command, Shift plus C, we can go for collapsing the tree. So let us see how it works. So whenever performing any of analysis, there have been a lot of requests from customers to enhance, like we should have an option where we can collapse simulation tree just by some clicks or shortcuts. We require shortcuts. So we had this Shift plus C option, which is available in SolidWorks itself. Now it has been added to simulation also. Just you can see in this one, if the tree is elaborated like this, so I can just press Shift plus C to collapse the tree, or I will get an option called collapse tree items. What you're seeing here, need to just click on the empty portions here, and automatically all the tree portions will get collapsed, and you are going to get this collapse tree of the simulation. Let us see how it works also. So let us see here, if I am having all the tree or the bodies displayed like this, I want to just collapse the tree here. I can just right click here. I can say collapse the tree items, or you'll get an options called Shift plus C. Directly all the things gets collapsed. So earlier we used to do using this arrow mark, so that has been eliminated. This is one of the enhancements which will definitely save the time, and it will ease the work of an engineer. To continue with, there is one more great enhancement. What it is ultimately one of my favorite enhancement in SolidWorks simulation. See, many cases what will happen here when you perform analysis, there are cases there where we have to ship the files from one location to another location, and we want to check out, or usually what will happen here, there might be some missing of the files will happen, the result files. So in that cases, we'll get an error message. We need to rerun the analysis. So that was the cases which all the designers have requested, take enhancement in that one. So we have a simulation evaluator which will take care of all these what are the challenges faced by the designer there. It will help us to verify and update or reattach the simulation results wherever you shared. And you can also in the beginning itself, you can check this simulation study setup also there, whether you have applied proper materials, whether the meshing is also properly done or not. That also we can check out. And you can also it is intelligent enough, it provides a feedback needed to move forward, and with the confidence also. Let us see here how it has been implemented in SolidWorks 2020 simulation. So just see here, you're finding some exclamatory symbol here that indicates there is a warning here in this simulation study. So let us go for checking out. So you'll get an option here, right click on the study, so simulation evaluator. So what you're observing here, first, based upon your priority, what you want to check out, you can go for setting up the priority also, or you can say for alphabetically also there. So first it is showing here the results file cannot be read. So it's showing that there is a missing of the results file is there. You need to just go and check for that issue there. I need to just click on this, edit the study properties, change folder. So automatically will be taken to the results folder location, where I can just go for and I can allocate which is the results file. So now wherever you save the results folder, so that will be fetched from that location there. If you are not done, so you can see that here I am not given a proper one, automatically is going to showcase an exclamatory also there. Along with that one, if I want to check whether I applied proper materials according to my requirement or not, so you can see the list of materials, and the body or the part name will be visible for you. And it's a great way where I can check whether applied materials with the different grades are also is done properly or not. Again, I said one more enhancement, that is one more say benefit of using this simulation evaluator is you can also check whether you have done the properly meshing or not. So meshing is a mathematical representation where it takes into account the shape and size of your component, so that your results will be as much as accurate as possible, because on which only we are going to perform the analysis also. So let us see here how we are going to use this simulation evaluator. Again, it's very easy. Just go for here, right clicking on the study. You are going to get this simulation evaluator. You can just scroll down. As I said, the mesh is the mathematical representation which will take into account the complete shape and size. So volume, what you are seeing here, no, they should be properly matched. If your element size is not good enough to take into account, so you can find out there will be some differences between the mesh volume and SolidWorks volume here. So this is a CAD model, what you're going to use it for analysis purpose. So this is a mesh volume. When you perform the meshing, it can be of mesh control, it can be of initial mesh itself. There you'll find the difference also mentioned. So it's a great tool to check for different parts and bodies also there, and we are going to get easily understand whether I have done properly the meshing or not, to get a proper results. So one more enhancement in this SolidWorks simulation user interface in 2020 is I can delete any of the studies without loading the results. I'll just show you in 2019 how it used to be. So earlier we used to just load the results, then we are going to get an option there where we can delete the studies as per my requirement there. So now here in this one we can directly go for the results. See here in 2019 in simulation there, I have to load, then only I'll get results for, I can delete, I would have deleted that study. Now that is completely eliminated. In 2020, I can directly right click here on any study without loading any of the results. I can delete that study itself. So this is one of the great enhancements again. So it will help every user to save the time which it would have taken for loading the results. So we have seen now how the simulation evaluator will help you to verify, reattach, and you can go for checking out the feedback also while performing the analysis there. And we also seen that one how the delete study without loading will help each and every user to delete the studies without loading of unwanted data. So this, what all the say improvements in 2020 is there, definitely it will help any analyst who are going to perform the analysis there to set up the simulation studies much more faster than before. Moving forward, there is enhancements in the beam elements also there. So all of you are aware of that one, why we go for different types of elements also, like solid tetrahedral mesh or the shell mesh, or you are going to go for beam elements. So beam elements are definitely helpful in saving the time of computation there, and they have a unique properties where they will take into account different degrees of freedom also. So now there is enhancements in beam elements where I can go defining the thermal loads on for the beam elements here. So let us see what are the things we can do here. As you are aware, like whenever you have a beam elements, there will be locations where we can apply the load in the form of in the joints or in the beam itself there. What you're seeing here earlier, this functionality was not available when you perform the thermal analysis there. So now from SolidWorks from 2020 onwards, the version onwards there, we can apply the loads on these beam members, beam body, you can say that, or in the joints. And it is applicable for beam elements as well as the truss elements also there. And it is not just limited to just linear static. You can perform it for use it for non-linear static also, frequency analysis, buckling analysis, and non-linear dynamic analysis also. And we are all also aware that one we have to perform the thermal analysis where I can take into the temperature distribution, and which can be included in the static or non-linear static analysis, where I want to perform the structural analysis there. So this is one of the very good enhancements there. A lot of people appreciated this one. So it will definitely help you to perform much more quickly the analysis. And these are some of the things what we can do it on the beams. Say for example, if you want to apply the temperature, yes, you can apply it both on the joint as well as body, and you can apply convection, heat flux, heat power, and radiation to ambient only. So these conditions you can apply all to the truss body there, or truss or beam body there. In joint you can apply the heat power as well as the temperature. So that's what we require, and it's definitely SolidWorks has taken care to add these functionalities in 2020 version. So this is one of the assembly of Omax. So what you are seeing here, so Omax, when you run it, so there will be hot fluid also will be flowing out. So for example, they are the pioneer in using this SolidWorks simulation when it comes to thermal analysis. There are a lot of structure members also included there, which can be affected by the thermal loads as well as structural loads. So I'll just show you results here. What you're seeing here, thermal loads. Now these are the beam elements. If you observe here, so this is beam elements what you're going to observe in this portion. So I can just apply any of the thermal loads as per my requirement, whether they are faced to the different temperature loads or they are exposed to the convection coefficients also. Another thing, this beam elements, again, as per your requirement, you can also use it to predict the shear force and bending moment diagrams, and we can combine these beam elements and get the results in the form of the shear force and bending moment diagrams also. So what you're seeing here on the beam elements, the temperature have been applied, and you can easily get the results as well also. And due to the thermal, it can have a displacement variations. It can also have a temperature distribution change. So all these you can now you can easily see on the beam elements also. So what you are seeing here, this options what you're seeing now, this type of what we had in static analysis, now it is available for the beam elements there for thermal analysis there, and you can apply the loads, temperature loads. It may be heat flux or convection. All these you can apply for the beam bodies as well as truss bodies, and at the joints you can apply the temperature again or the heat power. So this will definitely help us to for more realistic conditions when you perform the analysis. There is one more enhancement in the meshing there, what we call it as a mixed mesh there again. So what usually earlier used to happen is we can only perform like first all the elements can have a draft mesh or high quality mesh. So let us try to understand what you mean by draft quality. What you're seeing here, these are the first order elements, and these elements only had say corner nodes at this what you're observing here. In the high quality elements, it will be in parabolic what you're seeing here, and they will be having a mid nodes. So these elements will definitely have a capability of taking the proper shape of your products, and they can give you more accurate results than the draft quality. So that's difference between the draft quality and high quality. Now from the SolidWorks simulation 2020, what you're seeing here, you'll be there is a change in the icon shapes also there. This icon indicates the high quality and draft quality, and now it is possible that suppose you take out here this is uh, universal joint assembly, and suppose I'm only interested in some components to have a high quality, and which are the components which are having a just less interest for me, I can make them as a draft quality. Earlier it was only option was available where I can make it all as a high quality or all as a low quality. So what you are seeing here, this is completely we can mix up the different components, we can mesh them with the high quality and low quality also. I can just need to select this is a high quality elements. I can just say right click on this one and I can make it as a draft quality. It is this will help you to reduce the time and give the preference to the components where you want to perform where you are required to get the more accurate results. So in that cases, this enhancement will definitely will help you. So one more enhancements like there in the board connections here. Whenever we have working with an assemblies, we connect the assembly parts through the welded connections or board connections. So now there is a new enhancements called we have a distributed board connection there. So we used to connect use our SolidWorks users are happy to use a virtual boards, which will help them to avoid the interferences and they can add out all the details also there, or they can directly convert from the toolbox components. But what used to happen was when you use the virtual connections or virtual boards here, so it used to just give a rigid portions what you're connecting from the top portion to the head of that bolt to the nut connection there. So it used to be a rigid connection, and we have approached the SolidWorks from the different customers also. So they have requested like can you add out make it as a much more much more accurate results in the regions where the board connectors get interacting with the different components. So what you are seeing here, this is two cylindrical components are connected by a bolt which is having pre-stress load conditions of say 1000 Newton, and it is having no penetration contact. So when you compare with the earlier just a rigid board connections, now with the distributed board connection, you can see that much more the distribution is uniform, and it is much more realistic one what we are used to get it in the earlier versions. So this is one of the say good enhancements what SolidWorks has implemented, and definitely it will going to again help the user to get more say accurate results as well as a realistic distribution of the interaction between the bolt as well as the different components which are connected by them. So this is the displacements also, just observe that one, which is much more there, and you can avoid those singularities which you used to arise due to the interaction also. So you can also include the foundation boards here where you can just add up here. See, this is for fixed holes, which we consider it as a more conservative one, where you don't have the bolts model, or you don't want to define it just by virtual connectors also. So you can see that this will be much more say conservative one, which is for, and this is for the virtual wall with the hinge connections. So just a comparison here, how the distribution of the load will transfer from the distributed connection as well as the earlier rigid connections what you used to see here. So this load is getting much more distributed here, and these results are much more realistic as well as what you can say can be used so with confidence with all the analysis which requires to check the failure of the bolts. So these are the more enhancements what you have seen here in case of the bolt connections as well as pin connections. So similarly, you have also seen that enhancements in the mesh controls also. So this will help us to have a more accurate results, and wherever, and it will also help us to reduce the mesh quality wherever required, and the computation time will definitely will be reduced using this mixed draft high quality mesh. So there are further enhancements to determine the free body forces also. What you are observing here, this is an example of nonlinear analysis where this is a nonlinear contact type of analysis where the the connections between the two components is varying with respect to time, what you're seeing here. And here also when you see this metal ball when it falls on this structure, so how the deflection will have, this is a dynamic analysis what you're going to get it. So in these conditions also it becomes very important if I get to know that one how the free body forces are acting on the different bodies also. So free body forces, in the sense, if you're seeing in this image, I can get forces along x, y, and g direction, as well as the resultant also you can get it on the different components here. So this functionality was available earlier with the linear static itself. There now it is enhanced, it is added to non-linear as well as dynamic studies also. So it definitely it will help for designers to consider the large deformation, as well as it will help to avoid the manual calculations and expensive prototypes. If you want to see that one, how the variations of the forces will grow from initial to end condition there. So just an example here, just see that this is an assembly there, which I want, it's a nonlinear analysis there. I want to see the free body forces on the area of my parts. So I'll just go there and just go on selecting, this is an hopper assembly there. I need to just select the parts, and I need to just go for adding those parts in that selection box itself. When I say update, all the free body diagram, free body forces will be available for me to understand at each step. It is applicable for both non-linear static as well as non-linear dynamic also. So definitely this detailed output will help every designers to make their designs from better to best. So what you have seen till now here is the simulation evaluator, and you have seen that one, how the beams are now capable of taking the thermal loads, as well as we have seen that one, how the mixed mesh quality will help you to reduce the time. So all these enhancements are will definitely will help any designers to go for the fast and you can go for the speeding up the adding up the simulation study, as well as easy to perform the analysis there. And for accuracy results, this distributed connections, the mixed mesh quality, as well as the other enhancements will help you to for better results, and without affecting and decreasing your time to perform the analysis also. So this is what we had, a small presentation on the SOLIDWORKS simulation enhancement. Thank you all for attending this webinar, and we are again conducting the similar types of webinar. So please attend. It's a knowledge share only, and we are going to try to showcase what are the capabilities which you can utilize in day-to-day work.